Okay, so today we are going to talk about something called average rate of change. Okay, average rate of change. You guys have already seen average rate of change in a little bit different context. In linear functions, we talk about average rate of change all the time. We just usually call it something different. Okay, so in a linear function, average rate of change is slope. Okay, it describes average rate of change, slope in particular for a linear function, describes how x and y change as we look at a function. Okay, it's describing, remember rise over run? We're describing how my sort of vertical change happens in relation to that horizontal change. So that's what I'm using slope to describe altogether. Okay, if you remember, we have a formula to find slope. Looks like this, y2 minus y1 over x2 minus x1. I want you to notice y is that vertical axis, right? The y-axis is our vertical axis. So it should make sense when we talk about slope as rise over run, that we are looking in the change in y on top, that's our rise, our up and down, over the change in x on the bottom, that's our run, okay? You may also see slope described as what we call delta y over delta x, change in y over change in x, okay? So let's start with some average rate of change problems that we're familiar with. I would like you to find the slope for A and the slope for B. Find the slope for A and the slope for B. So for A, if we just use the slope formula, right? X1, Y1, this would be X2, Y2 for those of you who are labelers. So we would get 8 minus 4 over 3 minus negative 2. 4 over 5 is our slope between those 2 points described for A. For B, you can tell me that this is the point 0, 3, and this is the point 1, 2, 3, 4, 5, negative 1. And you can use slope formula. Okay, did anybody use slope formula for B? What did you do instead? You counted, right? You can like visually see the difference in the y and the difference in the x. So from one point to the next, remember we always read graphs left to right, just like words on a page. We're going 1, 2, 3, 4 down. And then 1, 2, 3, 4, 5 forward. So our slope would be negative 4 over 5. Okay, so you have done this with lines before. Okay, many times. So now let's talk about average rate of change for non-linear functions. Okay, and we're going to look at all different types of representations for today. So we've already seen a couple of points that I've given you. We've looked at a graph already. We're going to see a table next. We'll see some more graphs, not linear functions, and we'll talk about average rate of change there. We'll see some functions where we find average rate of change. Okay, we're going to look at all of our different representations here. Okay, so slope, again, is a rate of change. Rise over run, you were describing a rate to me. How far do I go up or down, and how far do I move forward? That's a rate of change, okay? Other functions also have rates of change. Now, for a linear function, that rate of change is constant, okay? Its slope is the same no matter where on the line I am. But for other functions, that rate of change is often not constant, and that's why we'll talk about that in terms of an average rate of change, okay? over this interval, what's my average rate of change? It may be a little bit different if I were to break it up into smaller intervals over the course of my function that I'm looking at. So we're going to talk about average rate of change for nonlinear functions. So the table that we have here shows the average price of gas in dollars over a period of several years. So from 2005 to 2012, what was the average price of a gallon of gas? Okay, and that's the information that I had here. Years, and then the average cost over that year. Now, obviously, the values that I have here in my costs are averages themselves, right? Because gas is not the same price all year long. It fluctuates day to day often. But certainly over months in a year, we're going to have some fluctuation there. So these are averages, these values here. And then what we want to find is the average rate of change over a period of several years. Okay, that's what I'm going to ask you to do here. So for A, what's the average price, average change in the price of gasoline per year over the period from 2005 to 2008? So in a table here, I'm going to treat these just like points. So 2005 is right here, and I'm going to treat that like the point 2005, comma 2.31. And then the other point that I'm looking at here, the other little sort of snapshot, is 2008, and the price in 2008 was $3.30. I'm going to treat this information from my table just like I treat points in XY tables. Now, before we find our average rate of change here, I want to point out, if I look at my X values here, I know it's labeled as Y for years, but if I look at my X values here, they're going up by 1, right? The change in our X, our input, right, goes up by 1. And then if I look at my Y, we go up, we go up, we go way up. Well, I guess not way, but we go up, we come down, we go up, we go up, we go up a little bit. So we're going up and then down and then back up. Okay? Not linear, right? Because if it was a linear function, it'd be going up all the time by the same amount each time, or it'd be going down all the time by the same amount each time. This is not a linear function, but we can still find that rate of change. We just call it average rate of change. So I'm going to find essentially the slope between these 2 points, right? Computationally, I'm finding the slope. So this would be, if you're a labeler, x1, y1, x2, y2. If you're not a labeler, that's okay. 330 minus 2.31 over 2008 minus 2005. So on top, my difference in price would be 0.99, 99 cents, almost $1. And the difference in time here is 3 years. And then we go ahead and divide that out. And we get 33 cents. Now, since we're dealing with money here, if this didn't come out to a value that made sense for money, we would have to round to the nearest penny. In this case, we're just fine. Okay, it came out to 33 cents. Now let's talk about what this means. So the average rate of change is 0.33. Great. Move on. What I'm going to ask you guys to do is actually interpret some of these values for me. So the first thing I want you to notice is that this is a positive value, right? It's 33, not negative 0.33, right? It's 33 cents positive, okay? That means we are increasing. Does that make sense? It's a positive value. So that means my rate of change is positive, means I am increasing, I'm adding each time. I'm adding each time. Just like when slope is positive, that means our line is going up from left to right. When it's negative, we're going down from left to right. Here, right? Slope was negative, we were going down. This slope is positive, that means I'm going generally up. Same deal here. We are increasing. Okay. So furthermore, remember this is an average, right? This isn't constant every year. So when I'm describing what this means, what I can say is that the price of gas increased an average of 33 cents per year, not 33 cents over that total time frame, right? If I look at 2005 to 2008, that's almost $1. That's not a total of 33 cents. We're looking at an average of 33 cents per year. An average of 33 cents per year from 2005 to 2008. This average that I found applies only over that period of time to 2005 to 2008. So for nonlinear functions, we need to be really specific when we're describing an average rate of change, okay? And so I want you to notice, if I look at each of those increments, that is not 33 cents, but close. That is not 33 cents. That is also not 33 cents. So if I zoom in to these smaller increments, I'm not actually getting 33 cents for any of them, but it's the average over that period of time. In some periods it was smaller, in some periods it was larger. This is the average price increase per year for that time. Okay. Now I want you to find the average rate of change for the price of gas from 2006 to 2010. Okay, so same idea as what we just did, but a different interval of time, 2006 to 2010. Don't forget to describe what you found. Did we get to here okay? Just the computation part? Okay. Now I need to make it make sense for the context of our problem. Does this decimal work for that? No, right? Money I need to round to the nearest penny. So I would use 0.06. What does that 0.06 mean in the context of my problem? Mm-hmm. That's perfect. On average, the price of gas rose, since this is a positive value, it went up by about 6 cents per year from 2006 to 2010. Okay, the price of gas increase or rose an average of 6 cents per year from 2006 to 2010. Perfect. Okay. Now, on the next page, I recopied the table. That way you guys wouldn't have to flip back and forth. Because I'm nice like that. Okay, this is exactly the same table. I just put it at the top of this page since we're still working with it. I would like you now to find for me which 1 year period had the greatest rate of change. Notice I didn't say greatest increase. I said just greatest rate of change. Okay, so you are looking at each year increment. So from 05 to 06, what was the rate of change there? From 06 to 07, what was the rate of change there? Okay, for each 1 year period, I want you to find that rate of change for me and then tell me which period had the greatest rate of change. Set up my intervals here. So we've got 05 to 06, 06 to 07, 07 to 08, 08 to 09, 09 to 10, 10 to 11, 11 to 12. Make sure you've got them all. If you're using slope formula, what's the nice thing about looking at 1 year periods? Yeah, I only have to worry about the price, right? I don't have to worry about that Y value because the bottom's going to be 1 each time. The first few, we already talked about a little bit, with the first example that we did with this table. 2005 to 2006 is an increase of 31 cents because it's a positive 31. 06 to 07 is 22 cents, so that's another increase. 07 to 08 is an increase of 46 cents. 08 to 09 gives you negative 89 cents. 09 to 10 is a positive 43 cents. 10 to 11 is a positive 74 cents. And 11 to 12 is a positive 10 cents. Now, before we answer part C, I want to remind you of the question that we just answered, which was what was the average rate of change from 2006 to 2010? Okay, so we're looking at about this period, and we got 5.5 cents. Notice if I zoomed in and I looked at those individual years, I went up 22 cents, I went up 46 cents, and then we lost 89 cents. We dropped by 89 cents, and then we went up by 43 cents. So if I had looked at individual years, I would have gotten a much different picture. But since I looked at all of that time together, I get 5 cents as my average. Okay. So when I look at those individual years, which time frame, which interval of time has the greatest rate of change? 2008 to 2009. Yeah. Now, since it's negative, what does that mean happened to the price of gas during that time? It got cheaper, right? The price went down, negative, so it went down. Okay. Interval of time over which the price of gas was increasing. Well, that would be definitely not this, right? Definitely not 08 to 09. That works for decreasing. So from 2008 to 2009, the price of gas was decreasing. I could also zoom out and look at a larger interval and find a time when the price of gas was decreasing. So if I talked about from 2006 to 2009, the price of gas on average was higher in 2006 than it was in 2009. So I could also say from 2006 to 2009, my average rate of change for that time period would be negative. Is that when we look at the specifics for years, does that seem like an accurate statement? Probably not. But if we're talking average rate of change, the average rate of change is negative there. Okay. Another reason that I need to make sure that we're reading problems carefully and reading information carefully. When was gas increasing? Somebody give me an example. 2005 to 2008. Are we comfortably increasing from 2005 to 2008? Are we increasing over every period, even from 2005 to 2008? Sure. Higher, higher, higher. What's another period of time when we're increasing? There's more than one year. 2009 to 2012. Price goes up, price goes up, price goes up. Sure. Could I look at a smaller window within each of those frames? Sure. I could say from 2005 to 2007. I could say from 2010 to 2012. Those would work too. Questions for me on our table problem, our table example? Let's look at a graph now. So for example 3, the bottom of page 24, our function g of t is pictured here for us. We've got this graph, okay? We want to find the average rate of change over the specified intervals, okay? You're going to see that I kind of change up the way that we represent intervals to get you familiar with all the types of notation that you could possibly see. So sometimes you'll see x equals to x equals. Sometimes you'll see this interval notation here. There are a couple other options that we'll see, at least one other option, I believe, that we'll see for some interval notation probably tomorrow, probably next time. But I just want you to be sort of familiar with all of our different representations here, but they all mean basically the same thing. So from this x value to this x value, what's happening? Okay, so we've got a parabola here, a non-linear function, and we're going to look at that average rate of change from when x is -1 until x is 0. So if we just look at this section of the graph, what's this section of the graph doing? Increasing, decreasing, it's constant. It's decreasing. So what do I expect to be true about my average rate of change here? It should be negative. Yeah, my graph is decreasing, so that should be negative. I'm going to go ahead and find those points and calculate it like slope. So from -1, our y value is 4. When x is 0, our y value is 1. So if I calculate this as slope, this would be 1 minus 4 over 0 minus -1. So -3 over 1 or negative 3. Okay, from this point to this point, my average rate of change is negative 3. Okay. Average rate of change is negative, my graph is decreasing from 0 to 2. So we know at 0, our point is 0, 1. And then at 2, when x is 2, we're right here. We're at 2, 0. What is happening to my graph? Not what is the average rate of change, but what is happening to my graph over this interval? It does what? It does what, sorry? It goes down and comes back up, right? Okay. Now, if I calculate my average rate of change, this would be 0 minus 1 over 2 minus 0. No, this is 1. Sorry, 1 for my y there. It's like, that doesn't seem right. There we go. So we get 0 over 2, which is just 0. What is the average rate of change telling me about my graph? Yeah, it's telling me my average rate of change over that time is constant. Okay. Remember, with non-linear functions, okay, this is giving me the average change from where I start to where I stop. So if I just looked at from here to here, did I change in y at all? No. Now, if I look at my actual graph, I can tell that there's a change there, right? But when we talk about the average over that interval, nothing. I didn't change over that interval. And then one more from 1 to 2. So 1, 0, and then 2, 1. If we just look at our graph over this interval, what's happening with our graph? It's going up, right? Okay. So what do I expect to get from my average rate of change? What kind of value? Something positive. Okay. So this would be 1 minus 0 over 2 minus 1. We get 1 over 1, which is 1. And several of you told me it's going up 1. Yeah. Not too terrible? Okay. I want to take a look at one more problem for today. Turn the page for me. So we've looked at a table. We've looked at a graph. I want to look at a function. Okay. We're going to find the average rate of change for this function on this interval. So again, a different representation for an interval here. Okay. I'm going to start by finding what those points would be. So 1, what, and 9, what. In order to figure out what those points would be, I need to use my function here. So I'm going to take my x values and plug them in to my function, see what their corresponding outputs are, see what their y's are. So f of 1 would be 3 times 1 squared minus 1. So that's 3 times 1 minus 1 gives us 2. So I have the point 1, 2. And then I also need to find f of 9. So that would be 3 times 9 squared minus 1. So 3 times 81 minus 1. That would give me 243. Subtract 1, 242. And then we find the average rate of change between our 2 points. 242 minus 2 over 9 minus 1. This actually divides evenly. And we get 30 is our average rate of change there. So between this point and this point, our average rate of change is 30. What does that tell you about the graph? It should be increasing. The graph is increasing over this interval. we're going to stop there for today. Tomorrow, we're going to continue to work on average rate of change. Okay, next time we're going to continue to work on average rate of change. We're going to see another function example. We've got another graph example here. We've got some tables that we'll see again. Okay, with this same idea. And we'll continue to talk about, based on the average rate of change, what does this tell me about my function? Okay, what does this tell me if I were to look at the graph? Am I increasing, decreasing? Am I constant? What do I expect?